All right, let's start talking about probability. First thing is we have to count. And the first task that I'm going to ask you to do, I'll write it out, but I'm going to have you pause the video and try it. I'd like you to write out what it looks like, all possible outcomes if you roll 2 dice. Okay, if you roll 2 dice, what are all the possible outcomes? I'll get you started. Certainly, if you roll 2 dice, it's possible you could get a 1 and a 1, or you could get a 1 and a 2. Those are some of the possible outcomes. Pause the video, write them all out. Okay. I just realized before I unveil my work, I actually did write them all out. Before I unveil my work, I have a question for you. When you were writing out the outcomes for rolling 2 dice, did it cross your mind whether or not 3 and 2 and 2 and 3 are considered the same roll? And what about 5 and 5 and 4 and 4 and 3 and 3? Do you count those once or do you count those twice? I think those are interesting questions. For now, we'll just leave them as questions, but I'm going to show you what happened when I wrote out all possible outcomes. Again, if you want to struggle with this for a little bit, hit pause so that you don't see my writing. But if you're ready, here I go. I'm going to go ahead and unveil what I've written. Voila! Okay, so if you look at how I wrote out all possible ways that you could roll 2 dice, you can see that I've included 3 and 2 and 2 and 3. Now, the other thing is that you'll notice that I only include 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6 once each. I don't have doubles of them. So there's a couple of ways to double check and see whether this is the correct number of outcomes to have. One way is to use fundamental counting principle. With fundamental counting principle, we say something like this. We say you've got 2 events, and each event is rolling 1 die. So I'm going to write this out, and I'd like you to write the word as well. This is event 1 is roll 1 die, and then event 2 is roll the second die, and that's how we talk when we talk about probability. We talk in terms of events, and then we also talk about something called outcomes. And as far as outcomes, what we say is when we roll 1 die, how many outcomes do we expect to have? So for this first event, rolling 1 die, how many outcomes do we expect to have? Well, we expect to have 6 possible outcomes because there's 6 sides on a die. For those of you who are unfamiliar with a die or a dice, let's take a look. I think I have an example here. Oh, there we go. That's what dice look like. Neat, huh? And they should have numbers 1 through 6 on them. So anyways, when the event 2 happens, when we roll the second die, there should be 6 ways that event can occur. And fundamental counting principle says is that if we're interested to know the total number of ways of this event and this event, in other words, if it's both, then what we do is we multiply to get the result. And we expect to have 36. These guys are called outcomes. And I'd like it if in your notes you had the words event and outcome here. And by the way, these guys over here are outcomes also. These are just, the 6s are both outcomes. It's just that this is an outcome of one event, and this is an outcome of one event. When we think about both the events occurring at this together, we multiply them and we get a total of 36 outcomes when we roll those 2 dice. Okay, I wanted to introduce you guys to this vocabulary, and I also wanted to, something else, is that this list of possible outcomes, it is known as a sample space. And I'd like you to add that to your notes. this guy is called a sample space. And we use sample spaces to help us to determine probability. If we can count all the different outcomes in a sample space, then we can figure out some probability questions. So let's start with one interesting probability question. How about this? What's the probability of getting doubles? Probability, you roll 2 dice, what's the probability of doubles? It turns out that using this chart makes it really easy. First, we look at the total number of outcomes you can have when you roll 2 dice, and that is 36. So on the bottom is where we always, when we're calculating probability, by the way, let's go ahead, this is probability. On the bottom, when we're calculating probability, there we go, this is always going to be the total possible outcomes. And I am hopeful that I'm going to see all these words when I look at your notes. Now on the top, we're going to look at all the number of ways that we could get doubles. In other words, for this specific event, this guy is also an event, is that we get doubles, okay? That guy right there, that's an event. And for the specific event, what I'm curious is how many ways can we get doubles? And if we look at this chart, and by the way, one good reason to write out charts like this is it makes it so easy to do the math. We can see that there are 6 different ways to roll doubles. There they are. So we'll go ahead and put that there. So the probability of rolling doubles, oh, by the way, this is the number of ways, number of outcomes for the event. This is number of outcomes for a certain event. Okay, there we go. Okay, and so let's go ahead and finish this up, and we'll just write that the probability of doubles, and we can reduce now. I recommend that when you're calculating probability, don't reduce to start with. A lot of times it's very useful to write the numbers out like this so we can see where they came from. This 36 represents all these guys, and this 6 represents just these guys. And but we can reduce in the end, and that reduces down to 1/6. We will also write probability in terms of decimals or percents. If we do the math here, let's take a quick look. That should be, let's go ahead and cancel this. It should be 1 divided by 6. That gets us 0.16 repeating. We're going to say that is approximately 0.17, and 0.17 is exactly equal to 17%. Okay, so there's different ways we can talk about probability. Probability, I'm going to write a little a compound inequality for you guys. Probability is always a number that is greater than or equal to 0 and less than or equal to 1. And it can be written as a fraction, a decimal, or a percent. If you guys get this down, this is a pretty good straightforward introduction to how probability works. One of the things you're going to do when you're working on problems is you're going to write out the possible outcomes, and you're going to then put total number of outcomes on the bottom, number of outcomes for your event you're interested in on top, and then you're going to do some light probability calculations.